Hi everyone. In this video, I am going to discuss about the problems on displacement transducers. So let us see how to solve those problems. A capacitive transducer is constructed of two plates having area of cross section 600 mm square and are separated by a distance of 4 mm. Is connected to a diaphragm gauge. When there is no pressure on the diaphragm, the output of the capacitor is 350 into 10 power minus 12 farads. If a pressure of 800 kilonewton per meter square is applied to the diaphragm, the average deflection in the diaphragm is 0.5 mm. Calculate the change in capacitance of the system. So here the type of transducer given is a capacitive transducer. So now we need to take the formula regarding to the capacitive transducer. Okay. So first of all, let us write the given data. So what is the data given to us? So given data. So distance between the capacitive plates is given. So write that. So initial distance between the capacitive plates. Between the capacitive plates. So that is, we take it as T1. That equals to how much it is given? 4 mm. So the distance of 4 mm is connected to a diaphragm gauge. So initial distance T1 is equals to 4 mm. Convert into meters. So it is equals to 4 into 10 power minus 3 meters. And next, what is the other data given to us? The output of the capacitor is given. So when there is no acting of pressure, when there is no pressure, the capacitance or the output of the capacitor is 350 into 10 power minus 12 farads. So then write that capacitance when there is no pressure. So take it as C1 equals to 350 into 10 power minus 12 farads, right? Then if there is a application of pressure of 800 kilonewton per meter square, then the diaphragm deflects through 0.5 mm. Suppose here I have taken a diaphragm, right? Initially it is the distance between the capacitor plates. So whenever I apply a pressure of 800 kilonewton per meter square, then the diaphragm deflects through a distance of 0.5 mm. So this is the new position of the diaphragm. How much distance it traveled? 0.5 mm. Then what is the distance between the plates? So initially the distance between the plates is 4 mm, but the top diaphragm is moved to 0.5 mm downward. So the capacitor one plate is connected here and another plate is this one. So the new position of the top plate is this one. Then what is the distance between the plates? So distance between plates. Distance between plates after application of pressure. After application of pressure, that is T2 equals to total 4 mm, 0.5 mm is reduced. So that equals to 3.5 mm and that equals to 3.5 into 10 power minus 3 mm. Then he is asking us to find the capacitance of the system after application of the pressure. That is C2 we need to find. So what is the formula for capacitive transducer? So C is equal to epsilon naught into epsilon r into A by T1, right? So now first let us apply this formula when there is no application of pressure. Then C1 equals to epsilon naught into epsilon r into A by T1. So substitute the values. So 350 into 10 power minus 12 is equals to epsilon naught into epsilon r into A by, what is T1 value? 4 mm. So 4 into 10 power minus 3. Then what is the value of epsilon naught into epsilon r into A is equals to 350 into 10 power minus 12 into 4 into 10 power minus 3. So it will be equals to 1.4 into 10 power minus 12, right? Now let us calculate the value of C2. So now apply the same formula for C2. Then C2 will be equals to epsilon naught into epsilon r into A by T2. So that equals to, if you see it here, epsilon naught into epsilon r into A. So that is 3, what is that value? 1.4 into 10 power minus 12 by T2 value is 3.5 into 10 power minus 3. So that equals to 400 into 10 power minus 12 farads. Right? So this is the new capacitance. Then what is the change in capacitance? So therefore, change in capacitance is equals to C2 minus C1. So what is C2? 400 into 10 power minus 12 minus C1 value is 350 into 10 power minus 12. So that equals to 50 into 10 power minus 12 farads, right? So like this, we need to solve the problems on capacitive transducer. So the terms are, so where C is the capacitance, epsilon naught is the permeability of a free space, epsilon r is the permeability of the dielectric medium, and A is the area of the plates, and T is the distance between the plates, right? So I hope you understand the problem. If you understand, please like this video and subscribe to the channel. Thank you.